Lesson 7-2, Day 2. Our learning target is I can use the properties of exponents to generate equivalent numerical expressions. Our essential question today says, how do you simplify an expression with negative exponents? We have two properties that are new today, the negative exponent property and the zero exponent property. The negative exponent property says that if you have a base with a negative exponent, it's the reciprocal of that same base with a positive exponent. And the zero exponent property says anything to the power of 0 equals the number 1. Now I'm going to show you an example where maybe you can see the pattern to see why these rules are what they are. So I'm just going to start with the number 5. So 5 to the third power means 5 times 5 times 5, which is 125. 5 to the second power means 5 times 5, which is 25. 5 to the first power means you only have one 5. And then we'd get to 5 to the 0 power, 5 to the negative first power, and 5 to the negative second power. Now, what I want you to look for is a pattern. So looking at these numbers, hopefully you can see the pattern that we're dividing by 5 each time. So 125 divided by 5, 125 divided by 5 is 25. 25 divided by 5 is 5. So if I continue that pattern and I divide 5 by 5, it gives me 1. Then if I continue that pattern again and I divide by 5, that gives me 1/5. And if I divide by 5 again, it gives me 1/25. Now 1/5 is the same as 1 over 5 to the first power. And 1/25 is the same as 1 over 5 to the second power. So can you see these properties in action by my example over there? So negative exponents are the reciprocal. So negative exponents are the reciprocal of positive exponents. And reciprocals are when you flip over a fraction, or as you'll see in our examples, we're just going to move. So negative exponents are reciprocals of positive exponents. So if it's on the top of the fraction, it's going to move to the bottom. Or if it's on the bottom, it's going to move to the top. And then anything to the power of 0 equals 1, kind of like an identity. Anything to the power of 0 equals 1. So even if it's something like 43x squared y, and it's raised to the 0 power, that still equals 1. Because if you think about 0, like 0 being how many times you multiply something by itself, then you're not multiplying it by itself at all, 0 times. And if you wrote it out like my pattern over there, every single time, regardless of what base you use, when you get to that 0 power, it's going to equal 1. It's like dividing something by itself. Okay, now we're going to start simplifying some expressions. Simplify each expression. Your answer should contain only positive exponents. All right, here's the deal. If you see anything with a negative exponent, circle it. And then the rule is, if you cross the fraction line, you change the sign. So cross the line, change the sign. So circle the negative exponents, and you are going to turn them into positive exponents. So starting on the top of the fraction, I'm going to cross the line, and I'm going to write it on the bottom instead, and it gets to be a positive. The one that started on the bottom, though, when I cross the line up to the top, that turns it into a positive. So I want you to look at that and make sure that you are okay with it. A reciprocal is when you flip over a fraction. That's virtually what I've done with that part right there. The negative exponents, I flipped them. The one that was on the bottom went to the top. Top went to the bottom. Now they're positive exponents. Here's the deal with that y to the 9th though. It already had a positive exponent, so it stays right where it was. And that's your simplified answer. Now this next one, maybe you can do on your own. So circle the negative exponents. Those are the ones that are going to move. So remember, if you cross the line, change the sign. Cross the line, change the sign. Put this one on the bottom, put this one on the top. And they're both positives. And then n to the 5th stays right where it was. Okay, now, little bit more going on in this problem. Still, circle the negative exponent, okay? And I'm also going to circle, well, maybe not circle, I'll put a rectangle around the 0 exponent. So the negative exponent is going to move. So cross the line, change the sign. The rest of them, d to the 2nd, e to the 5th, oops, there's another one down here that needs a rectangle around, and then f to the 4th. Okay, the rest of them are good. Now, here's what happens with those 0 exponents. If you remember that anything to the 0 power equals the number 1, you can change those into 1s. And when you multiply 1 times something, you're not changing it. So I actually can just ignore those 2 terms. They're gone. Now, I'm not done simplifying. So when it says simplify each expression, you can only see each letter once. So you may or may not need to expand this. It's totally up to you. I'm going to expand it just so that you can see, if you're a visual learner, what's happening. Okay, so now what has happened here? On the top of my fraction, I have 4 f's, so that's f to the 4th power. On the bottom, I actually have 5 d's now, so d to the 5th power and e to the 5th. Your simplified answer can only have each variable in it once. You can't have 2 of the same letter. If you have 2 of the same letter, you're not done simplifying. Okay, x to the 0, and then we've got 2 with negative exponents. So first thing I'm going to do, cross the line, change the sign, z to the 5th, y to the 1st. If you're doing this assignment with your iPad, you can change colors like I just did. That really helps me see which terms I've already used and moved and which ones are left. So I can see I've got my y to the 4th left, my x to the 2nd, and z to the 2nd. Now on this problem, x to the 0, that just turns into 1. 1 times 1 is 1. And on the bottom I have 2. 1/2 doesn't simplify. You don't have to write the 1 on top of the fraction, but I'm going to leave it there for now. So now if I simplify this, I've got my 1/2. I have y to the 1st and y to the 4th. Remember, you don't have to put the dots in between them. z to the 5th, x to the 2nd, z to the 2nd. So on the top of my fraction, I have 5 y's. So 1 y to the 5th, or just y to the 5th. On the bottom, I've got my 2. I have 2 x's, and I have a total of 7 z's. So this is my final answer. Y to the 5th over 2x squared z to the 7th. Next up, negative exponents. There's 3 of them. No 0 exponents this time. Now, the first thing I want to do on this problem is deal with the 75 and 15. Those coefficient numbers, those numbers, they're not exponents, they're coefficients. You reduce like a regular fraction. So I know I can divide them both by 15. If you did not know that, maybe you divide by 5 first, then divide by 3. So dividing by 15 gives me 5 over 1. So 5 over 1. Now, let's move these. M to the 5th goes down to the bottom. Both of these go to the top. M to the 4th, R to the 8th. And then what's left? P to the 3rd, P to the 5th. Okay, now Look at it in expanded form. M to the 4th, R to the 8th, P to the 3rd, M to the 5th, P to the 5th. Okay. Now, if I cancel out, because I see that I've got M's on the top and the bottom of the fraction, so remember we need to reduce by canceling. So cancel them in pairs, and you've got one M left on the bottom. Same with P's. Cancel them in pairs, 2 P's left on the bottom. So my answer this time, I don't have to have the 1 on the bottom. I have 5R to the 8th on the top of the fraction, and on the bottom 1M and 2 P's. So 5R to the 8th over M P to the 2nd. Next one, 5 over negative 20. Reduce it like a regular fraction, the coefficients. Remember the negative on this 20, it's not an exponent. So you're not moving it. You're not moving the negative 20 to the top of the fraction. That doesn't make sense for the coefficients. So dividing both by 5 gives me 1 and negative 4. When you have a negative sign on the bottom of the fraction, I prefer instead to put it on the top. So when you divide one positive and one negative, it is a negative fraction. But I want it to be on the top of the fraction, not on the bottom. So negative 1/4. Circle, circle, move. R to the 3rd to the bottom, U to the 5th to the top. Remember, after you move it, it's now a positive exponent. The rest of these stay where they were, and then you can expand it. So negative 1/4, U to the 5th, T to the 4th, R to the 3rd, R to the 2nd, T to the 7th. All right, canceling this time. The U's are not going to cancel. They're all on the top, so there's 5 of them. The R's are not going to cancel. They're all on the bottom, and there's 5 of them. The T's, though, those will cancel. So there aren't any left on the top. There are 4 left on the bottom. So my simplified answer is negative 1 U to the 5th over 4 R to the 5th T to the 4th. You don't have to have the negative 1. You could get rid of the 1, but keep the negative sign like that if you like that better. Last example, 2/10. You can divide by 2, divide by 2, so that gives you 1/5. Circle the negative exponents. This one's got kind of a lot of them. So C to the 5th is going down to the bottom, and then to the top, A to the 3rd, B to the 1st, C to the 4th. And then I leave the A to the 2nd and B to the 3rd. Okay, so expanding on this one. 3 A's, a B, 4 C's, 5 C's on the bottom, and then on the top I've also got 2 A's, 3 B's. So my final answer this time, let's see what we've got. Some C's that cancel, 4 of them, and that's all that cancels. So on the top I've got 3 A's. Oh no, I've got more than 3. I've got some over on the other end. I've got 5 A's altogether. And then B's, I've got 4 B's altogether. And on the bottom, just 1 C. So A to the 5th, B to the 4th, over 5C. And that was our last example.